Good morning, YouTube. So we have a nice, comfy Saturday morning here. We're going to continue on with SHSAT-like ISEE problems. Um, they're going to be consistently very SHSAT-like. So good morning, Leo. I'm Greg at GregsTutoringNYC at gmail.com. I'm a private tutor who tutors one-on-one, and also I'll tutor people in groups anywhere. I normally meet at people's homes, but I also do libraries, coffee shops. I even met a group one time out in the park. So that's the deal. Am I still on? I just got a warning message from YouTube. I don't really get on. I don't understand YouTube. Anyway, we're just going to jump into things. Somebody emailed me after the last one, so I'm going to relook at a problem just for the sake of clarity. Actually, how about we actually solve it this time? Because we applied logic on it the last time. All right, so let me drag me off to the side because I'm not important. All right, so we should have problem number 17 showing on the screen. And let me move this. Let's see here. Let's move this like that for now and see how that makes out for us. All right, so we're going to revisit problem number 17 because to me the logic flowed, but it doesn't matter what it means to me. It matters what it's meaning to you guys. So that's the kind of feedback I need from people. In fact, I guess this is a confusing question. So let's kind of look at it again. Number 17. John and Aaron were both jogging on the same path, each at a constant speed. So there's John, there's Aaron. They're jogging along. They're both at a constant speed. Okay? And Aaron is faster than John. So John has constant 1 and Aaron has constant 2. Their own respective constant speed. So John, for instance, might be going 5 miles per hour or meters per minute. And Aaron might be going 10 meters per minute. Okay? So what we're doing is we're reading a sentence at a time. We're starting to fill in information as we do it. Okay, we don't know these are real numbers. In fact, the problem never gives us numbers. So we might as well stick to simple numbers like this. I'm picking 5 and 10 on purpose, particularly because of that 500 there. But instead of picking, say, 2 and 3 or 7 and 22, I'm trying to pick a number that seems to jive with 500 somehow. That at least if I have to multiply these, they're divisible into the 500. So I'm using my number sense to try to figure this out. Still don't know what the question is. Actually, I do know what the question is, but let's assume it's the first time you're seeing it. This is the kind of things you need to think about and do, okay? So that you want to make the math easy when you finally get to solve whatever the actual problem is, all right? So when Aaron started jogging, John had already gone 500 meters. So there's a start point, if you will. John's already got 500. Okay, at this point, this is the timeline when Aaron starts. Okay, Aaron's still over here. So at some point when he's finally at 500, she starts. Okay? Then what one piece of additional info in meters per minute would be needed to determine how long in minutes? So after some amount of time, or we could just use uppercase T here. After some amount of time, let me make sure this is showing on the screen. Yes, it is. Let me make sure the stream is still going. Yes, it is. All right, so after some amount of time, let me bring the problem back in front of me. After some amount of time, which one piece of additional info and immediate limit would be needed to determine along how many minutes Erin has been jogging when she caught up with John? So at some point along here, so let's call the end, both John and Erin are both at some certain line in time. All right? So this kind of question, I would hope, because it says what one piece of additional info in meters per minute, I was hoping that would be a hook. But when you look at all the answers, A is about a speed, B is about a speed, C is about a speed, and D is about a speed. So the fact that they put in meters per minute, that was kind of just the distraction. I don't know if the test writer did that on purpose or it was just for some sense of clarification. But the answer, whatever, they're all speeds. So they have to be in meters per minute. All right? So the problem is, how do we solve how long it would take? If we actually wanted to solve t to get to the endpoint, how do we solve that? So that's really what the question comes down to. All right? And the meet point is because Erin goes 10 meters per minute. Equals 5 times John plus 500. Okay, and this E and J here, this is a 5. This E and J are going to represent the feet they went in. So how do we solve that? They're both going to go with the same timeline at that point. So we're going to subtract and get 5t equals 500, and then t equals 100. All right? We can plug that in because it means that Erin went 10 times 100, so she went 1,000 feet, okay? And John went 5 times 100, which is equal to 500. But he already went 500, so he also went 1,000. So that jives. So the question is, when I did the 10t minus the 5t, that's how I got the answer. And that's why the answer is D. It's a subtraction. Okay? All right, so 17. We did 18 the last time. We did 19. Did we do 20? Yeah, we did 20, I believe. Where's 21? We did 21 as well. Yeah, we did 21. 22 we skipped because I thought it was going to take too long. We're running out of time. By the way, I'm going to go about maybe 40 minutes to an hour. I'm going to keep it under an hour. We're on the 13th one of these. Yeah. All right. Okay, so this is a standard 2-equation problem. When you see something like this, think I need to set up 2 equations. So a parking meter, actually let me make sure this is showing on the screen right, because I shifted stuff around. Yeah, that's good. Okay. A parking meter filled with $4.50 in dimes and quarters contains twice as many dimes as quarters. And a dime is worth 10 cents, and a quarter is worth 25 cents. I'm not sure why they're giving that. I believe it's because this test is giving internationally as well, but I'm surprised they don't have a conversion somehow. But in the event, it doesn't matter. They're defining it for us. So we have to compare column A with $3, the total value of the quarters. So we need to resolve somehow how many dimes and how many quarters we have. So when there's two things like this, we're trying to solve for two things. We normally do something called simultaneous equations, and you could either solve them by figuring out what the equations are and then replacing one equation with the other by substituting, or by subtracting the two equations and then solving for one of them. In both cases, you're going to end up solving for one, and once you get the one, you're going to solve for the other. So in this case, what would our two equations be? And again, you can pause the video. My phone is wiggling around, sorry people. You can pause the video and try to solve this yourself. Okay, in the meantime, I'm going to jump right into this. Let me bring it up on my screen first. I had too many windows open. So a parking meter is filled with $4.50 in dimes, and they're telling us a dime is worth 10 cents, and 25-cent quarters. So you can keep this in the decimals, but if I notice if I multiply both sides by 100, I'm going to have whole numbers. You may or may not have to do this, but I generally like to do this, so I'm just going to be left with this. And I could have wrote it this way in the first place. Basically, 450 cents. Instead of $4.50, 10 cents, and 25 cents, I'm going to say 450 cents equals 10 cents per dime plus 25 cents per quarter. Okay? The other thing we know is that there's twice as many dimes as quarters. So there's either one or two formulas here. We could just write it out if you can't think of this. There's twice as many dimes as quarters. So if there's 1 quarter, there's 2 dimes. Okay, that works. So these are our two equations. So in this case, it actually gives us a way to substitute. So what we're going to do is stick it in here. And by the way, up here we could have wrote, 25Q plus 10D equals 450. It doesn't matter which way we do that as long as the equal is being presented properly. Okay? So anyway, Q equals 2D. So we're going to get 450 equals 10D plus 25 times 2D. So we get 450 equals 10D plus 50D. So we get 450 equals 60D. Something seems to have gone wrong here again. I'm too lethargic again. Twice as many dimes as quarters. $450 in dimes and quarters. There's twice as many dimes as quarters. I'm noticing this because this math doesn't work out. Twice as many dimes as quarters. Nothing like doing a live stream and getting stuck. This happens to all of us. Let's see, what did I do wrong here? I did something wrong. Let me write it out again. Parking meter is filled with dimes and quarters. 10D plus 25Q equals 450. Contains twice as many dimes as quarters. I had that backwards. All right, I said before that was okay, it's not okay. So we get, now if we substitute, we get 10 times 2q plus 25q equals 450. We get 20q plus 25q equals 450. We get 45q equals 450, and we get q equals 10. If q is 10, then d must be 20. If we plug it in, we get 200 cents here, and we get 250 here, and that does equal 450. All right? So that's not what the question is yet. So it says the total value of the quarters, if there's 10 quarters, that's 250. So we have 250 versus $3. All right, so question number 22, the greater value is going to be B. All right? All right, so when you get a brain fart like that, like I just had, or I screwed it up, you have to know you're doing it wrong, okay? And there's often ways to do it. I just started with a clean piece of paper. That always helps too. And just reset your brain. If you get stuck like that, skip the question. If you can't resolve it quickly, you guys have a timeline. I don't. And then you can continue on. Everybody's going to make that kind of mistake, okay? I make it all the time. You guys make it all the time. The question is, how do you solve it when you run into an issue like that? Okay? All right, so what do we have here? 22. I think we did 23. I think we did 24. I think we did 25. Where's 26? I don't think we did 26. So let's do that. So, on the ISEE, actually this whole section, they kind of half suggest that you actually don't have to do all the math. And they're just trying to see that you can reason things out and making a mathematical assessment of what some of the situations are. So but let's start out just trying to solve it formally. So it says the product of 3 consecutive integers is 210. Is means equal. So the multiplication, the product, right? When we multiply 3 consecutive integers together, we get 210. Or 210, not 210. The question is, do you know what a consecutive integer is? It means they follow each other. It's like 99, 100, and 101. All right? So if we represent that algebraically, and there's a couple ways to do this, but one is x times x plus 1 times x plus 2. And there's a couple ways to, so we need to expand this out to try to solve for x. All right? And the problem on something like this is I'm going to FOIL these two first and then just throw the x in afterwards. So I'm going to get x squared plus 3x plus 2. Okay? And I'm going to apply x to that whole thing. So I get x cubed plus 3x squared plus 2x. Okay? So this is already into hard math. Most kids are not going to be able to solve this and go, duh. All right? Now, I'm not saying this is unsolvable, because at some point it's going to equal the 210, right? The 3 products was equal to 210. So there might be some smarty stuff you can do in here. I actually haven't thought enough to see if there is any, but it's just not worth it. It's just not worth it. Because if you look at the problem and try to assess it, it says the greatest of 3 consecutive integers. We're talking about the product of 3 of them. So if we look at 10, if we do 10 times 10 times 10, 10 times 10 is 100 times another 10 is 1,000. We're into an astronomical number at that point, compared to 210 at least. All right? So that means column B has to be larger. Yep, that's the answer B. So just logic shows this. We can also double check it, because when when we're kind of doing this here, since they're so close to each other, you can kind of semi-estimate and say x cubed equals 210. This is incorrect, but it's a leg up. So we're really saying x is equal to the cube root of 210. Okay, so what times what is about 210? So if it was 10, we already know we're in 1,000. So 10's too high. If we did 5, right? So we're going to get 5 times 5 times 5, right? That's 25, and that's equal to 125. So that's too low. If we did 6, again, we're estimating here. We get 36 times 6. What is that, 218 or something? 198. So we're super duper close here. So the answer is around 5, 6, and 7. Right? I made a guess. And I'm actually going to try it now. So this is 30 times 7 is 210. So that actually turns out to be the 3 numbers. So we did it without doing this craziness here. And we did it pretty rapidly. Anyway, you actually didn't need to go and do the 210 part. You didn't need to figure this out. When you got to 6, you went 10. You knew 10 was too high because that's what they gave you in column B. I just halved it. I'm doing what's called the binary search. You start somewhere. You have a bunch of stuff. You start in the middle. Where's the camera here? You start in the middle, and you go on one side or the other of it. And every time you go, you can go back and forth. By the way, when you have your A, B, C, D choices, on something like the ISEE, they're in order. So sometimes it's not worth picking A and then going through B and C and D. Start with either B and C, and depending on, in the cases where they are in order, then you can decide whether to go this way or that way. In the SHSAT, there's no guarantee they're in order. So this, what I just said on the SHSAT doesn't work. Okay? But for the ISEE, it will. Okay? And it's just a strategy to save time. It's a test-taking tip that's independent of things. So in any event, we figure out the answers 5, 6, and 7. And the greatest of that is 7. So 7 is definitely less than 10. So this is kind of a cute one. Of course, the SHSAT won't give this column A and B thing, but it'll change the question to some other form where it would match up. All right, let's make sure we're still going live. Yes, we are. By the way, please like and subscribe. Thank you, people. Share as well. Doing a lot of hours here. Hopefully it's benefiting you guys. All right, that's 26, 27. Let me see if I have scrap paper. Okay, 27 is going to compare 25n minus 1 versus 25 times n minus 1. You could do the distributive property. You can make the first one distributed with a fraction. You could also map out the second one. But I'm okay leaving the both of them. And they're not giving you any other information about the two columns. So what we're kind of going to do is, what about n greater than 0, n equal to 0, n less than 0, and n between 0 and 1. So when these kind of questions come up, this is the kind of categories you have to test. In other words, they're not saying it's only positive integers. They're not saying it has to be whole numbers. So over here, we could be testing, say, a half. Because weird things happen with fractions between 0 and 1 sometimes. Especially with subtraction involved and stuff like that. So with those in mind, let's compare column A and B. So when n is greater than 0, let's just use 1. So when n is 1, we get 24. Right? Because we get 25 minus 1 is 24. And when n is 1 here, we get 0. So A is larger right now. When n is equal to 0, okay, here we get minus 1, and here we get minus 25. So A is still larger, right? Minus 1 is greater than minus 25. Okay, less than 0. So if I did minus 1, so I get minus 25 minus 1, I get minus 24. Okay? If I do minus 1 on the other, I get minus 1, which is minus 2, and I get minus 50. Okay, minus 50. So these A still wins if I'm doing all my math right. And then I'm just going to stick something in like, let's work with a half. So we have 25 halves, which is 12.5, minus 1 equals 11.5. So for that we get 11.5 here. And if this is, and by the way, this sometimes you want to try this between minus 1 like that as well, and 0. You want to do the fraction on both sides of the 0, between 1 and minus 1, okay? What do I have again? I was doing a half. So I have n minus 1 is minus a half. So I have minus 25 over 2. So I have minus 12 and whatever. So I get minus 12. So A turns out to be the winner in all the scenarios here. Okay, so we beat it to death. And this is a problem that could take a while. Maybe there's something that leaves out here that I can't see, but this one is just taking the numbers and going through them. I don't see any other way to do it. All right, so column A is the winner, I believe. Let me see. Yes, okay. All right, 28. Okay, 28 looks like an easy peasy one. Let me make sure we're still going live. By the way, if you guys have any questions or you want to interact, by all means, please do so. All right, so we have a square and a rectangle. Okay, so it says, note, figures not drawn to scale. And they want to compare column A, which has a spelling error, doesn't spell the word column right, with column B. So column A is looking for the perimeter of square A, and column B is looking for the perimeter of rectangle B. So first of all, I don't know why they gave both numbers here, but what we're going to do is we can double these and get 1.5x, and double it again and get 3x, right? Or we could just 2.75 times 4 and get the 3. Okay, this, we have y plus this, we get 1.5. And we can double that because there's a couple of ways to do it. We can do y and then 1.5, 0.5 here too. Or we can get 1, 2, 3. How we do it? We get 3. So most people are going to say these are equal, but they're not. They are not. Can anybody see why? Because this is an x's. This is 1.5x giving us 3x. This is 3y. So which is larger? The answer is we don't know. If we go back to the criteria that they give us, the relationship cannot be determined from the information given. All right, 28. 29 is a question I actually despise. Out of many test questions, this is one that I kind of had a problem with. Not so much that they couldn't answer it, but it's just an annoying question to me. And I'm left asking myself, well, what about the other situations? So first of all, let me just make sure it's showing on the screen. Yeah, it is. Okay. So a 6-sided number cube, numbered 1 through 6, is rolled, and a coin is tossed. So we have to assume they're both fair. The coin isn't weighted. The cube isn't weighted. It's not slanted. They're both right angles. Yada 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 yada. Okay. So normally when it's rolled and it's tossed, we get either heads or tails or 1 through 6. Okay, so column A says, if a number less than 3 is rolled on the cube, the probability of the coin landing tails up. You go like, huh? Because that's just worded strange to me. And B says, if an odd number is rolled on the cube, the probability of the coin landing heads up. But if we just take them each by face value, okay, if a 3 is rolled, right, the probability of a coin landing tails up is 50-50. Because the probability of a coin landing face up is 50-50, whether the dice was rolled or not. Okay? B is the same kind of situation. If an odd number is rolled, because they're not talking about if an even number was rolled. And the same with A. They're not talking about the number greater than 3 was rolled. They're given this exact scenario. If a number less than 3 is rolled, the probability of the coin landing tails up is 50-50. Same with B. If an odd number is rolled, the probability of coin landing heads up is 50-50. So they're both 50-50. So they're both equal. Okay, it sounds kind of weirdish, maybe even unintuitive, but intuition is often freaky. So turns out they're equal. Okay, you probably won't have a question. I'm going to say this easy on the SHSAT, but it's actually not an easy question. It could throw a lot of kids, and that's kind of the thing we want here. And again, the SHSAT would probably give A, B, C, D, or it might be a grid-in. It might say subtract the 2 probabilities or something. And you'll get 0, obviously, in that case, okay? Or something like that. Or what's the sum of the 2 probabilities? It'll be 1, because it's 50-50 plus 50-50. Okay, 30. And make sure this is showing on the screen. Wait. Yeah, I think we should be okay. Let me just make sure that's right. Yeah. All right, so we have an illustration. Again, I look at the illustration first. It just so happens to be first. So I see it's about exam scores. Sometimes the title of the illustration could be at the bottom. It could also be at the top. You analyze the illustration, try to make sense of it, look at any captions, legends, all words they give, all numbers they give, and try to make sense out of it. And again, I'm going to point this out that it has a kind of thing here. That means they're leaving that out. That's absent because it doesn't apply. They're only comparing things apparently between 51 and 100, and they don't care about stuff, say, between 0 and 51, okay? So I'm going to look at it. It's exam scores. It says the number of students. So again, they're talking about a frequency that, for instance, 4 students got between 71 and 81, and 7 students got between 71 and 90, because 4 plus 3 is the 2 categories added up. And there's nothing really earth-shattering here. So I believe I understand the table. And I can run through and do, normally when they have a figure like this, they're going to ask for the median, the mean, or the average, the range, or the mode, okay? Okay, the mode is 4. The range is 100 minus 51. The median, we could go through and get, we're going to get rid of the 2 ones on both sides. We're going to do 2 there. I believe the median is the 71 through 80 range. I'm doing this on my head. And the average, you would actually have to add them up. The average is hard here because each category is ranges. So it's technically not an average. You would get an average of the ranges. In other words, we don't know that one of the exam scores was 75. We just know it was between 75 and 81. All right. So, and you're going to do this analysis in a snap thing. It just took me 2 or 3 minutes, but I'm explaining this live. You're going to do an instantaneous decision. Look at the figure, decide what's going on, ask yourself maybe 1 or 2 quick questions, and move on to the question. So the histogram shows exam scores of students in mathematics class. Whoopsie-doo. Okay, column A, the median score. B, the range of the scores. Okay, so I'm just going to pick the range. The range goes from 51 through 100. It's the min minus the max. The min minus the max. Okay? So I'm going to get 100 minus 50. No, 100 minus 51. And I'm going to get 49. All right? So I'm going to compare 49, which is B, with A. And it says the median score. Well, 49 doesn't show on the thing. It's in the squiggly area right here that they don't show. That's where 49 is. All right? So that just means without computing the median, we know that A has to be larger, because A has to be somewhere between 51 and 100, and that's not it. So if we go, before I did it in my head, but let's actually do it. What do we have? 4. That's going to be 2. That's going to be 1. That's going to be 3. It's sloppy. So we have 1, 2, 3, 4. We're going to have, this is 1. So that's 51 through 60. The next one is 2. And again, you're going to do this on your test paper. You're not going to need to copy this over unless you get really sloppy. That's 61 through 70. 4 is 71 through 80. The next one is 3. And that is 81 through 90. And the next one is 1, which is 91 through 100. So what I'm just going to do is go back and forth on these counts. This is 1 and this is 1, so I can get rid of this. Okay? This has 2, so I'm going to get rid of 2 here. And I'm left with this now then. So this is my median. I just know it because I'm going to get this about this point right here when I go back and forth on those. Okay, the other way to do this was just to list them out. I have 51 through 60 one time, and I'm going to do them in order. I have 61 through 70 twice. Okay. I have 71 through 80 4 times. I have 3 81 through 90s. Because some people can't do this visually, and I have 191 through 100. So this direction, I'm going to go this way and down, and this direction, I'm going to go this way and up, because they're in order. I could have written out a giant list here, but so if I cross this off, I go to this side and cross that off. Okay, if I cross this off, I'm going to cross this off. If I cross this off, I'm going to cross that off. Okay, if I cross this off, I'm going to cross this off. If I cross this off, I'm going to cross that off. And I'm left with that number. That's my median. All right, so we did it the same way. So there's kind of 2 things here. One is to look at the problem, because you don't want to go through all that math just to realize, oh, column B was 49. You know what I'm saying? So you have to make snap judgments and do your math sense live and simultaneously sometimes. All right? Let me make sure we're still going live. Speaking of live, yes, we are. All right, so we're going for going about 40 minutes right now. Let me see what questions we have left. Maybe we could stop here. Yeah, let's do that. Let's stop here. Hopefully everybody has a nice weekend. Today doesn't seem too bad, although I think it's going to end up just as hot. seems to be a beautiful day out. I'm going to do a lot of work inside the house. I got a bunch of stuff to move around here, and I'm going to tutor another kid online later, so I have to get set up for that. Again, please like this video, please subscribe, please share it. There's a lot of kids taking the SHSAT who are not getting up to speed in their classwork. For starters, because you know, there's a lot of discussion about test prep and all this other stuff. But the truth of the matter is, there's a lot of schools that suck. There's a lot of teachers that suck. There's a lot of kids confused. There's a lot of schools where they're not teaching the full curriculum. You could argue maybe they shouldn't teach the full curriculum anywhere, and they should lessen standards. But that's a different argument, given that's what New York State is requiring. That's part of the situation with grade 5, 6, 7, 8. And here we are. So I'm trying to bump you guys up to the next level. Again, I do private stuff where I can crawl in your brain and really help you guys. All right? So I may do a lightning round later on today. I have tons of material that I just feel I need to get out there for you guys. I really like helping kids get along and move further, especially geeky kids. I was a geeky kid. I still am a geeky kid at heart. And I love talking shop with people, which in this case is math and tinkery stuff and just stuff like that. So, all right, I'm rambling again. So everybody have a nice day, and I will see you again. I might do another one of these tomorrow morning. I have to see. If not, you know, I'm going to keep on your backs as well. All right, people, email me for help, and see you later, alligator.